Greetings and welcome to another fun video from iCampSA. So today we are looking at the Newton's laws again. Question 2 from 2024 May-June question paper. Okay, so let's hear what they are telling us here. So they're saying block A of mass 4.1 kg is connected to block B of 2.3 kg by a light inextensible string passing over a frictionless pulley. This is a pulley. Block A is at rest on a rough surface. So now we should note we have something here which is rest, then we've got rough horizontal table. Okay, then block B hangs vertically as shown in the diagram below. Okay, so one of the things to note is that at rest it means the velocity here is 0. And then a rough surface or rough horizontal table, we should expect a form of friction here, right? We should have frictional force acting on this block here, block A. Okay, so then the start we are asked here about state the Newton's law, second law of motion in weights, right? So we should be able to state that. So remember here we are talking about this law. So it's 2.1, you know that Fnet is equals to MA, right? So now we need to put this in weights. So this here in weights, we can say when a resultant force or when the net force acts on an object, the object will accelerate in the direction of that force. Okay, so if the net force is going to the left, then that means these blocks are going to go to the left. If it's to the right, it's going to go to the right, right? And then it tells us that acceleration is directly proportional to the resultant force, right? So that means if we increase acceleration, we are increasing also the resultant force, okay? And then it's inversely proportional to the mass of the object. So that means if you increase the mass, then the force will then decrease. Okay? So the acceleration, actually, the acceleration is going to decrease, right? That's what is happening here. If you increase the mass, the acceleration is going to decrease. So let's write it in weights. There it is. So when a resultant force acts on an object, the object will accelerate in the direction of the resultant force. Then we say the acceleration is directly proportional to the resultant force. That means if you increase acceleration, you increase the resultant force. And acceleration is inversely proportional to the mass, right? If you increase the mass, that means you're decreasing the acceleration, right? That because a mass is a constant, so you can't alter the acceleration. So right, so what happens is if we change the resultant force, we increase it, the acceleration is going to increase. We're increasing the force that we are applying to an object, right? So then we have 2.2. They are asking us to draw a labeled fluid body diagram showing all forces acting on block A, right, while it accelerates to the left. So now this is on a flat surface, right? So let's start with a dot to show that this is the body. It's a free body diagram. We have a dot here. Since it's on a horizontal surface, we know that here we're going to have normal force, right, which is N. And then we have Fg, which is your weight, right? And then we have, this is gonna be tension because this is connected by a string, right? And then if you can see here, this box is moving to the left, and here we are told that this is a rough surface, so we're gonna have friction here. That means there's frictional force that we are going to have here, right? So now we have about 4 forces. Then the last one then becomes the applied force, which is like so. right? This is going to be your F, which is 49 newtons. You have simply drawn the free body diagram that they were asking you. This is free 5 marks. So you have how many forces? 1, 2, 3, 4, 5. 5 marks. Okay? So sometimes you can use these marks to determine the number of forces that are expected from you. Okay? Cool. So then let's move to 2.3. So now they're asking us to calculate the magnitude of the kinetic frictional force exerted on block A. Right? They're asking us for this force. How do we then calculate this force? Let's go back to our statement here because we didn't finish it. So they're saying here the force F of magnitude 49 is applied on a block A at an angle 50 degrees to the horizontal, causing the block to accelerate to the left from rest, right? So then the coefficient of kinetic friction between the surface is this. This is it here, right? This one. So now if they are asking us to calculate, let's do this. If they are asking us to calculate frictional force by block A or experienced by block A, so let's do this. We know that frictional force is like so, mu K, because it's moving, so it's kinetic friction. Then we have normal force. Okay? Naturally, you are used to the normal force being equals to Fg, right? So you are used to be like this. But this is a special case, right? It's no longer like this. It's not going to be like this. So why? Because we've got another force here. If you come here, we can end up with, let me draw it like this. So I'm going to use dotted lines. Let's use a special color. So this is going to be F parallel. And then there's going to be a force that's going up like this, right? So this is going to be F. Let me use X and Y, right? Then we've got something, these two components of F, which is our applied force. So we need to accommodate that. So that means our F, our normal force is no longer equals to mg. Okay? So let's calculate it. So now we've got this y component, which is Fy plus n, right? Why am I adding these two components here? These two forces that are going up, because now we've got something like this. If I can update my free body diagram for you, we're gonna have this, which is Fy. Then we're gonna have your normal force. This is gonna be normal force, and then what do we have? We have your Fg here, right? So we need to do a net of this, because they are not moving up and down. The object is not moving up and down, but it's moving only horizontally. So it means these two forces, these three forces, the two going up and the one going down, are going to be equal, like this. So if we add these two, because it's not moving, right? So if you take this Fg to this other side, the Fnet across this is 0. Right? It's 0 because it's not moving up and down. We should note that. So then we have this. So that means then our new normal force is going to be Fg minus Fy, like this. And then we've got our new normal force. Okay? So let's go back and substitute our stuff. So remember, we must know that our components here, we've got components. This is theta, and then this is opposite. We're going to have components. This is sine. So Fy, remember, components, force components, right? So we've got Fy being equals to what? It's going to mg sine theta. Then Fx equals to mg cos theta. right? These force components, you should remember that. So then we come here, we have this like K, then our normal force is Fg minus Fy, like this, right? So we've got all of this. So this is gonna be mu K, Fg is mg, this is weight, minus Fy is mg sine theta, like this, right? No, it's not mg, it's F. So this is supposed to be F because we are talking about the component of F. This is F, right? We are talking about this force here. So then we have, this is 0.35, mg is 4.1 times 9.8 minus F is 49, sine theta is 50, like so, right? Then you punch in this to the calculator, then you should get our answer. So then this is our answer, right? Here they were looking only for the magnitude, right? And we know that from this is going to the right. The friction is going to the right. Okay, so let's look at the last question. So here they're asking us to calculate the magnitude of the acceleration of block A, right, by applying Newton's law on each block separate. So that means we're gonna do block A, then we're gonna do block B. So that's what they want. Okay, let's go. So starting with block A, let's start with block A. This is block A here. Block A, we already have our free body diagram, right? So the updated free body diagram should be something like this. Let's draw it. This is the free body diagram for block A, right? So we are considering only the horizontal movements, right? We're not going to deal with, for block A, with the vertical movements, right? So we've got Fx, Fk, then T, then Fg, okay? So now let's go with Fnet. So we now want acceleration. Fnet is equals to what? Ma. So Fnet, so we will have to choose direction. Let's choose, if we choose to the right, as to the left as positive, so we can say to the left, this side is positive, then this side is negative, like so. So that means Fx, we're going to say Fx is going to plus, to the negative is Fk minus Fk plus minus T, which is our tension, then equals to Ma, like so, right? And then we go with, remember for our Fx, this is Fx is F cos theta minus, we've already got this Fk here. We've already gotten it. So it's not an issue. So we're going to say 0.93, then minus T equals to, the mass is 4.1 times A. We don't have A, right? So here, instead of using this F, actually, we can just substitute everything and say 49 cos 50 minus 0.93 minus T equals to 4.1A. This is our first equation, right? So we can work, let's work around this so that it's much easier for us, okay? So we can just say here 37 minus 4.1A being equals to T. So we can say this is our equation 1. Then we need equation 2. So let's then get equation 2. Equation 2, we're going to get it from block B, right? So let me draw a free body for block B. Now here, this is our free body for block B, right? So we're choosing up as positive and down as negative. So then we do an equation for this. We say Fnet is equals to MA again. So positive is going to be T minus mg equals to MA, like so, right? So then we can then say minus mg, we've already 2.3 times 9.8, g is 9.8. Remember, g is a constant gravitational acceleration. Then we have 2.3, then we don't have a, we are looking for a, right? And then we've got this beautiful thing here. We can even go further and say t is equals to 2.3a plus, and then let's punch this to a calculator. It's 22.54, like so. Yeah, that's the one, right? And then we've got equation 2. This is equation 2. This is t here, so that means these two are equal, right? Because it's t, both sides, they are going to be equal. So we can come here to another page. We can take this equation here. We have taken these two equations, right? So now these two equations, we know that equation 1 equals to equation 2, because this is t, they are equal. So we can go further and say 30.57 minus 4.1a is equals to what? 2.3a plus 22.54, like this, right? So then we can transpose. We're gonna have, because we're trying to group the like terms, this is gonna be minus 22.54 if you bring it to the other side, to the left. Then we're gonna take 3a, then we're gonna take 4.1 to the other side, also to the positive, to the right side. So now we've got something like this, right? Let's play with our calculators. So now, after playing, we've got this here, right? So then we're gonna just divide both sides by 6.4 so that we are just left with a only, right? So this goes away, we are left with a. So this is equals to 1.25 meters per second squared. So now we have gotten our acceleration, right? That's how easy it becomes. Okay, this is the end of our session. Because this is going to the left, this is gonna go to the left side because we are dragging these boxes to the left, right? So this is the end of our session, guys. Hope you enjoyed it and understood.